So, hello and welcome everyone. So, am I audible? Can I get a confirmation in the chat box? Yes or no? Okay, I think I'm live. Okay, so yes or no? Okay, okay. So, uh, am I audible clearly? Can I get a confirmation? Uh, is there any background noise available with my the sound of my fan or anything? And please mention it right now so that uh, the audio quality can be more better. Is my voice clear? Can I get a confirmation, please? Okay. Okay, so we are good to go and let's start the session. Let me share my screen. Okay. I've shared my screen. If not visible, please mention it. Okay. So today in this video, we're going to solve the problem of the day, and that is of 29th March. The name of the question was count the substrings, and it was pretty easy to understand. The problem statement was pretty clear enough, and the solution also. So, were you able to solve this question? Yes or no in the chat box? How many of you were able to solve this question? I think almost everyone. Hello, Naikach. Hello. How many of you were able to solve this question? Okay. So, the name of the question is count the substrings, and the difficulty level of this question is easy. So, let's first of all read down the problem statement. The problem statement goes like this: you'll be given a string S, and the task is to count the number of substrings which contains equal number of lowercase and uppercase letters. Okay, so we have to find out how many substrings are there which contains equal amount of lowercase and uppercase letters. So let's understand with the help of a test case. So over here, first of all, I would like to explain what is a substring. So what is a substring? So substring contains the contiguous characters present inside a string. So it can't be it cannot be you cannot break that sequence. Let's say if the string was a b c d e f and g, so b c d e is a substring, cd is a substring, but a e and f is not a substring, it is a subsequence. Okay, so that was all about substring. So what the question says, that how many substrings are possible that contains equal amount of uppercase and lowercase letters. So I can see one substring, this one, GE. One more substring is EK, equal amount of uppercase and lowercase. It contains one uppercase and one lowercase, both of them. And one more entire string, it contains two uppercase letters and one uppercase letter, right? So in total, how many substrings are there? There are three substrings, hence the output for this test case comes out to be 3. Was the question explanation clear to you? Yes or no in the chat box? A quick confirmation, and then we'll move forward. So in this today's lecture, like in this question, like I will explain the part 2 of this question. Okay, and it would be very interesting. And if you develop that kind of thought process for every question which you are solving, then it would be very easy for you to crack any of the interview, because that is the thought process which the tech giants are looking for in the candidate, right? The engineering mindset. Okay, so we have to find out how many total substrings are there which contains same amount of uppercase and lowercase characters. Okay, so the question is pretty easy to solve if you know how to find total number of substrings, or how to find all the substrings in a given string. Then the question is very easy for you. You have solved almost 60% of the question. So let's see. If I say that I have to find out all the substring of this string, which are the substrings? I'll note down all the substrings: GE, GE, GEE, and the entire string is also called a substring. The other part is E, double E, and double EK, and the other possible string is E, this one, and EK. Okay, so this many substrings are possible. So how will you find all the substrings? So over here, if you observe carefully, in this set of substring, the character starts with the zeroth index. The zeroth index character has been taken in this manner. In this set of substrings, I have taken the substring starting from the index number 1, this substring. And over here, I have taken the substring starting from the index number 2, this one. And one more string is possible, that is the substring starting at index number 3, the last one. A single character will be there. Okay, so this one. So over here, this can be obtained by using simple nested for loop. You can iterate over the entire string. The outer loop will iterate over all these indexes. Over here, what is the length of this string? The length of this string is equal to 4. And the outer iteration of the for loop will be over the first character of this substring. So that would be from I is equal to 0 to I is lesser than n. N is the length of the string. Okay. So now, where will I keep the other end of the string? The ending part of the string. So that can begin from, for each and every string, if you observe, it can begin from the same index. Over here, if you observe, the ending index is 0, ending index is 1, ending index is 2, ending index is 3. It can begin from the same index, as well as it can go to the length minus 1. Over here, the ending index is itself 1, 2, 3. This is 2, this is 3, this is 3. So I can observe that every time I can begin the loop with the outer for loop variable. So the inner loop will run from j is equal to I to j is lesser than n. So that means I will be able to find out every substring. Is this part clear or not? A quick confirmation in the chat box. Yes or no? Can I get a confirmation? A quick yes or no? Okay. So this is the method to find out all the substring. Now in each substring, what you have to do? So in each substring, I have to find out the count of uppercase and lowercase characters. So what I will be doing, I will be simply counting the characteristic of the character. That means if it is a uppercase character, I'll be increasing the uppercase counter. If it is a lowercase, I'll be increasing the lowercase counter. Right? So I'll be needing two different variables. That would be uppercase, it will be initialized to 0, and lowercase, it will be initialized to 0. And over here, while iterating over each and every string, I will increase either of this counter. If the character is uppercase, I will be increasing the upper counter, lowercase, then lower counter. And I will be counting how many times the count of uppercase and lowercase character is equal. As many times you find this operation, this equation to be true, you count how many times you find this equation to be true, and that is going to be your answer. So I will be needing an answer variable, and answer variable will be denoting how many substrings are possible. And whenever I see this expression to be true, I will be increasing my answer variable. That means I have found a substring containing lowercase and uppercase count to be equal. So I'll be checking if the current character, and let's say the name of this string is str. It is str is the name of this string. So if the current character, I'll be writing down one function, is lower, that will return me true if the character is a lower character, is a lowercase character. So str of I, that means str of j. the current character. Is that character a lower character or not? Lowercase character or not? Yes, then I'll be increasing the lower counter. If no, then that means obviously it is going to be a lowercase character, right? So there is no requirement of creating another function that will check whether the character is uppercase. Else I will be increasing the upper counter. Okay, that's it. And now I simply need to check this condition. Okay, so let's copy this condition. Is this true or not? Yes. If this is true, increase the answer counter and the outer for loop will end, and the inner and outer both of them will end. And at the end, simply you need to print the answer variable. You simply need to print the answer variable, and this is our brute force approach. This is our brute force approach. Is it clear or no? Yes or no in the chat box. I think it will be clear to all of you. And after this solution, here comes the part 2. So first of all, I want to know, is it clear or not? Yes or no in the chat box. Okay, thank you, Rishit. So talking about the time complexity of this approach. Okay, so the time complexity, the outer for loop runs n number of times. Okay, thank you everyone for the confirmation. And the inner for loop runs n number of times in worst case. So how many iterations are there in worst case? There would be n square number of iterations in worst case. So the time complexity comes out to be n square. And the space complexity, have you used anything that depends upon the size of the input test case? No, I haven't taken any of the space that depends upon the input test case. So the time complexity comes out to be constant in that case. Is this pen color visible, or do you want me to change the color of my pen? I think it's visible to all of you, right? Okay. So the time complexity comes out to be order of n square, and the space complexity is constant. And let's see the feasibility of this solution. So let's go to the constraint part. Okay, so constraint says there would be 10 to the power 3 length substring possible. The length of the maximum string is 10 to the power 3. So let's see this many iterations are feasible or not in 1 second. That is 10 to the power 6. Yes, exactly, you can do 10 to the power 6 iterations in 1 second, and this solution is going to be it will be accepted. There won't be any difficulty in the acceptancy part. Okay, so I think everyone will be able to code this part, but then I will be explaining you how to check if the character is a lowercase character of or an uppercase character, right? If you know that in the memory the characteric values are stored by their ASCII values, right? An ASCII value is an integer. It is a decimal value, or you can say it is an integer value, right? So you can simply check the ASCII value of capital A and capital Z if you want to check whether the character is an uppercase, or if you want to check whether the character is a lowercase, you can compare the ASCII value of your current character with the uppercase and lowercase characters A and Z. So let's say if you want to check if it is an uppercase character, just compare the ASCII value of current character. Okay, if this character's ASCII value lies in this range, then it is uppercase character. If the ASCII value of the character lies in this range, in this lowercase a and lowercase z, then that means it is a lowercase character. A simple comparison needs to be done in order to identify whether the character is an uppercase or a lowercase character. Yes or no in the chat box? A quick confirmation in the chat box. Okay. So let's code this part, code this solution. So I'll be needing an answer variable. I'll be coding in Java, but the same can be implemented in other languages as well. Only there would be a difference of syntax. Okay, so now I need to iterate. I will be iterating over the length of the string. So I'll be naming it as str.length and I++. So let's change the name. It's str now. And now inside it, I need two different variables. Integer, lower, I'll call it as lower, and upper. It denotes the count of lowercase and uppercase characters. Now the inner for loop will run from I to length of this string. Lesser than length of this string. And I will be checking whether the character is an uppercase or lowercase. So I'll be needing a simple condition. The first condition to check if the character is a lowercase. So I'll be checking if it lies in this ASCII range or not. So let's first of all extract the character. So CH is our current character. I'll be comparing its ASCII value. If it is in this range, then I'll increase the lower counter. Else I'll increase the upper counter. Okay, and inside this, at this point itself, you have to check because this inner for loop indicates the end of the substring. So if lower character counter and upper character counter are equal, increase your answer variable, increase the value of your answer variable, and at the end simply return this value. So you can simply return this answer value. That's it. Let's compile and run. Any doubt in the implementation part? Okay, so I forgot to. AND operator was required. I forgot the AND operator. Any doubt in the implementation part? Yes or no? If it lies in this range, what is the issue? Let's see. Answer is 0. Lower is 0, upper is 0. Okay. Just give me a minute. Okay, so over here I accidentally used the outer for loop variable. No, that was not the issue. I placed I over here. I have to place J because J denotes the character added to your previous substring. Right? And let's try to submit and see whether it gets accepted or not. Yes, obviously this will be acceptable because it follows the time constraint. It is inside the time constraint, and the time constraint was n square, and we did exactly the same solution. Right? Now if I was the interviewer, I would have asked you the same question. I would have asked you the same question, but I would have increased the constraint and I would have said that what if the length of the string in worst case was 10 to the power 6 or 10 to the power 5? Then this n square solution will not work. It will not be acceptable in order of in 1 second. This many iterations. Let's say if the largest string given to you was of length 10 to the power 5, then in worst case 10 to the power 10 iterations you will be making, and that is not acceptable in time complexity order of like in 1 second you cannot do that many number of iterations, right? So we can find order of n solution as well. You can solve this question in order of n. Do you think can we do it in order of n? Yes or no in the chat box. So here is the part 2 of this question. Okay, I was very excited for today's POTD because the question was easy, but we can think a lot about this question. So we have already got the acceptable solution, but here comes the efficient approach. Can I do it in order of n? Yes, we can do it in order of n. How? Let's say over here we have only two different categories of characters. Either the character will be an uppercase character or the character will be a lowercase character, right? And the count of upper and lowercase character in the substring which I can include in answer needs to be same. Count should be same. So if the count can be same, then that means your upper case counter minus your lower case counter will give you a result 0. How to generate AKL? Okay, so if the count of uppercase and lowercase in every answer substring is same, then the difference will be equal to 0. Do you agree or not? Yes, yes, exactly, Rishi. You can convert this question to a very standard problem or a very famous problem of arrays, that is count given an array, count the total number of subarrays with sum equal to 0. You might have done this question, yes or no? Right? That question was already a part of POTD. I guess like 2 months back, that question was already given to you as a POTD. So you can convert this question into a that kind of question. So what I'll be doing whenever I find a character that is uppercase character, what I'll be doing, I will be calling all the uppercase characters, and whenever I see uppercase character, I will be considering them as +1, and whenever I see a lowercase character, I'll be considering them as integer value -1. Okay, I have converted it into a integer value 1 and -1. Okay, so whenever you see that a substring contains same amount of uppercase and lowercase character, then that sum of that substring, if you convert it into +1 and -1 according to this, then that sum would be equal to 0. So you can count how many subarrays are there which have sum equal to 0. So let's take this entire string GEEK. So I will not be explaining that entire question again, because the solution part and that it is an entirely different question. So I'll be simply explaining you quickly that how you can convert it, and then I'll be coding down the solution. Just a little bit part of the algorithm I'll be explaining. Okay. So uppercase, for uppercase I'll be using, let's say, +1, and for lowercase I'll be calling them as -1. And one more thing, let me explain how that count the subarrays with some 0 question was done. So let's convert it first of all. So upper, this G is a lowercase, so -1. This E is a uppercase and lowercase. So now in this array, you have to find out how many subarrays are there having sum equal to 0. So that question was done by counting the frequency of the sum which you have encountered till now. So initially you take a sum variable is initialized to 0. Now you start iterating and you keep a hash map that denotes over here, that denotes the sum, and over here it denotes the frequency, how many times that sum was encountered. Right, currently the hash map is empty. Now -1 is encountered, so adding it to sum, so sum becomes -1. So now here you will be checking whether this value is already present or not. If it is present, you will be fetching that value from the hash map and adding it to your answer variable. That value is not present, so I'll be making an entry inside my hash map, -1 encountered only once. So moving further, 1. So adding it to your sum variable. So adding it to my sum variable, and the sum is 0. The sum is 0. So whenever the sum is 0, or you find the sum to be present inside your hash map, you will be increasing the answer variable. So when will you increase the answer variable? So whenever you find this condition, when the sum is 0, increase your answer variable by only 1. No, it's not required. You can do it in that manner as well. Over here, whenever you encounter a sum 0, you can increase the answer variable as well. So this will provide the same functionality as you have mentioned. Okay. And do you actually know what is the meaning of doing this thing? Why should we add the sum there is other way of implementing as well, which Rishit has mentioned in the chat box. He says that we can add the sum variable 0 with frequency 1 inside the hash map as your initial step. So do you know why do we do that thing? Okay, no problem. I'll explain that part as well. So whenever I see a sum equal to 0, I'll be adding it to my answer variable. Only one value should be increased. Or the other condition is, if the sum was already present inside your map of sum is not equal to 0, then whatever value is inside the map, you will be adding it to your answer variable. You will be adding it to your answer variable and increasing the frequency of that sum in your map as well. Prefix subarray with sum 0. Okay, I'll explain it. I'm not sure uh, about the approach which you are saying, that prefix array kind of, but I don't think there is anything related to prefix array in that. Okay, so these are the two conditions. So I can see one of the condition is satisfied, so increasing the answer variable by 1, and moving forward, so I see 1 increasing the sum by 1. Now do you find sum inside your map or not? So I cannot see, so no increment of your answer variable. Make an entry of 1 inside your hash map. So moving forward, -1 was encountered. What did you encounter? -1. So on encountering -1, you observed that 0 was present. But one more entry is required, that when you encountered 0 for the first time, I forgot to make an entry inside the hash map. So inside the hash map, 0 once will also be present, because over here you observe, if you observe, here the sum was -1, here the sum was 0. So I forgot to make this entry, so I have mentioned it right now. Now again the frequency, when the sum came out to be 0. So over here the increment of your answer will be done twice. Here sum has been 0, so increment the answer, both the conditions are true. Both the conditions are true. Sum is equal to 0, increment the answer by 1, so answer will be 2. And the next condition is also true. Inside the hash map, sum 0 is already present with frequency 1. So whatever is the frequency, add it to your answer variable. So this will be your final answer. And now make an entry of this sum, current sum 0, inside your answer, inside your hash map. So sum will be equal to 2. I mean the frequency of 0 will be equal to 2. And there are no remaining characters of this string. Yes. To accommodate the subarrays that are starting from the 0th index. So at the end, you have encountered every character of the string, and over here the answer came out to be 3, and that is your output. That is your output. Is it clear? Yes or no in the chat box? If you don't know how to find out the count of subarrays having sum 0, I would suggest, after this lecture, read out that solution, try to solve that question, and you will observe the similarity between both of them. Okay. So what will be the time complexity of this approach? The time complexity of this approach, if you want me to write down, frame out the entire algorithm, I can do that as well. Let me frame it out first of all. So I'm just writing down the statements. Okay. So first statement is, consider uppercase will be considered as 1. You can consider the vice versa of it as well. Lowercase will be considered as -1. Now what you will be doing, you will be needing a map. You will be needing a map which will store sum and its frequency as a key value pair. It will store the sum and the frequency as a key value pair. Now after doing this thing, we need an answer variable. Answer variable will be initialized to 0. Now what else do I need? I need to iterate over each and every character. So I'm just writing down what all things which I did over here in terms of steps, and this is the algorithm framing. This is what I call algorithm framing. So I'll be iterating over each and every characters. I is lesser than n. N is the length of this string. So now what is the current character? I'll be checking if uppercase character You can check either of them, right? If it is an uppercase character, I will be adding 1 to my current sum. Over here, one more variable is required, that is sum variable, that will store the sum till now, a value for each and every subarray found or the substring found. So I will be adding 1 to my sum if the current character is an uppercase character. Else, what I'll be doing, I will be subtracting 1. So I'll be adding -1 into my sum. And now I'll be checking if the sum value is 0. Now I need to update my answer variable, right? So if the sum value comes out to be 0, so I'm writing down these two conditions. These are the conditions when you will be increasing the value of your sum variable. So if the sum value is 0, increase the value of your answer variable by 1. Else, there is one more condition, not in the else part. These two condition uh, can be true at the same time, right? So if you find the sum, if you have found the sum present inside your map, if the map contains is not equal to false, if the map contains, I'm just writing down the algorithm, it is not any kind of syntax, so do not interpret this part with the syntax of map used inside your C++ language. Okay, so if the map says this value is present, or let's say the frequency of it is not equal to 0, then I will be increasing the value of answer by whatever value is present inside the map, whatever frequency of that sum is till now. And then at the end, simply increase the frequency of that sum inside your map. This is the entire solution. This is the entire thing which you do in finding all the subarrays having sum 0. This is the same algorithm. And at the end, the last step is to print the value of your answer variable. That's it. This is the entire algorithm. Is this part clear or not? Yes or no in the chat box. A quick confirmation in the chat box. And then we'll be discussing the time and space complexity. Okay. So if I talk about the time and space complexity, so over here, how many times are you iterating over this string? Over here, I can see an iteration. I'm iterating over this string only once. That is n number of times. And do you see any kind of iterations? No. The operations on the map are order of 1, so I will not include it over here. So the overall time complexity comes out to be linear, order of n. What about the space complexity? The space complexity, in worst case, it can be equal to order of n because you are using a map, or it can be order of n minus 2. But in worst case, you can take it as order of n. So this is the time and space complexity. You have compromised a little bit on the space in order to achieve the efficiency in terms of execution time, in terms of time complexity. Earlier it was order of n square. The space complexity was constant, but you have used some of the space to optimize the time, right? We need to give something if you want to do something, right? If you want to achieve anything. So this is the entire solution in linear time. Okay. So we can code this part quickly and we'll end the session afterwards. Was this clear to you? Was this clear to everyone? Yes or no in the chat box? A quick yes or no or +1 in the chat box. Okay, so let's code this part. I'm coding over here in Java, but you can do that in C++, Python as well. So let's first of all change the name of this argument, str. Right? Let's keep it str. For space complexity, y order of n minus, not n minus 2, n by 2. Let's say alternate minus 1, 1 were given to you, something like that. Try to create a test case. The time complexity will be some part of n, not exactly n, because it is not at all possible that you can. Yes, you can. It can be order of n because let's say you get all the characters to be minus one, or you can get all the characters to be one. In that case, you will be storing some 1, 2, 3, 4, 5, 6, and so on. That is equivalent to the length of the string. So the time complexity, I mean the space complexity, will be order of n. Okay. I was giving you a rough idea that I was thinking it will be some part of n, not exactly n, but I got a test case in which we can see it will be order of n in worst case. Okay, Rishit. So now let's start. We'll be coding according to the algorithm which we wrote just right now. So first of all, I'll be creating a hash map, and the hash map will be capable of storing key value pair, and both of them will be of integer type, right? This is how I create hash map in Java. It is a class over here, right? So that's why we need to write the syntax to create an object. So I have created over here one more variable, that is the answer variable is required. And what else do we need? We need one more variable, that is the sum variable. And now we can iterate over each and every characters. First of all, I'll be storing that character in some variable as ch, just for the tidiness of the code. And now I'll be comparing and checking if this character is a lowercase or not. So let's say if it lies in this range, and it is a lowercase. So for lowercase, I said that you will be indicating the lowercase with minus 1. So you will be adding minus 1 to your sum. If it was uppercase, I'll be taking it as plus 1. Right? That's it. And now I need to check if this sum is 0 or not. If the sum is 0, what you will be doing, you simply need to increase the value of your answer variable by 1, by 1 unit. Okay. And if the sum value is already present, if it is present inside your map, then what you will be doing, you will be increasing the value by whatever frequency is present inside your map. If it was not present, then this condition will not be executed. Else, you will be simply needing to make an entry inside your map. Or if the value is already present, you simply need to increase the frequency. So I'll be updating the frequency in this manner. So this will be initializing the frequency to be 1 if it is not present, else it will be increasing the previous value by 1. So this is the syntax for achieving the same in Java. This method get or default, it will be initializing. If it will be present inside the map, it will be returning the value. If it is not present, it will be returning the default value passed as the second argument. Those of you are coding in Java, if you don't know this method, it's very useful. Learn about this method, get or default, the method of your hash map, right? And that's it. You simply need to return the answer variable. Let's compile and run. Sorry, the plus one was over here, not out of this part. Right, let's try to submit and let's see the acceptance. Right, the solution is accepted as well. Wasn't it an interesting question? Don't you think this was an interesting part, an interesting way you can think about different questions? A quick yes or no in the chat box, and we'll be ending the session over here only. Any doubt till now? Anything you would like to ask me or anything? Okay, so I see no doubts coming. So we'll be ending this session here only. It was great interacting with you. So we'll be ending this session here only, and best of luck for the next problem of the day. Right. So thank you everyone. Thank you. Bye bye. Good night.